Welcome to Module 2, Tuple. In this lesson, we will focus on how tuples work in Python, especially how the code executes and how outputs are produced. Tuples are similar to lists, but with one important difference: they are immutable, meaning they cannot be changed after creation. This slide summarizes key ideas. Tuples are ordered collections, just like lists, but they are immutable. This means once a tuple is created, we cannot add, remove, or modify its elements. As shown in the diagram, tuples also support indexing, slicing, unpacking, and operations like concatenation. A tuple consists of a number of values separated by commas, enclosed within parentheses, and the values cannot be updated/changed. Python refers to values that cannot change as immutable. Tuples are enclosed in brackets, can be thought of as read-only lists. Tuple can contain different data types collection. Let's go through the examples step by step. First, my_tuple equals, this creates an empty tuple. Next, my_tuple equals 1, 2, 3, this creates a tuple with 3 integers. Then, my_tuple equals 1, hello, 3.3, this tuple contains mixed data types, integer, string, and float. Finally, my_tuple equals mouse, 8, 4, 6, 1, 2, 3, this is a nested tuple. It contains a string, a list, another tuple. Even though tuples are immutable, the list inside can still be modified because lists are mutable. Here, we see that tuples are ordered and indexed starting from 0. For example, my_tuple equals 10, 20, 30, index 0, 10, index 1, 20, index 2, 30. Tuples also allow duplicate values and mixed data types, similar to lists, but they cannot be modified after creation. Let's analyze this code carefully. First, my_tuple equals 3, 4.6, cat. Even without parentheses, Python automatically packs these values into a tuple. Next, print my_tuple, output will be 3, 4.6, cat. Now unpacking, a, b, c equals my_tuple. This assigns a equals 3, b equals 4.6, c equals cat. Then, print a, 3, print b, 4.6, print c, cat. So unpacking splits tuple elements into separate variables. When creating a tuple with only one element in Python, it is necessary to include a comma after the element, otherwise, Python will not recognize it as a tuple. This is because parentheses are used for grouping in Python, so without the comma, Python would interpret the expression as just the value inside the parentheses rather than as a tuple. This example shows an important concept. First, my_tuple equals 1, the comma is required. This tells Python that this is a tuple. So, print, type, my_tuple, output, class, tuple. Now look at, not underscore a_ tuple equals 1, there is no comma, so Python treats this as an integer, not a tuple. So, print, type, not underscore a_ tuple, output, class int. The key idea: a single element tuple must include a comma. Let's examine the tuple. Fruits equals apple, banana, cherry, date. Fruits 0 returns apple, fruits -1 returns date. For slicing, fruits 1:3 a start at index 1, banana stop before index 3 include cherry, so output is banana, cherry. This follows the same slicing rules as list. A certain elements or range of elements from a tuple can be retrieved by creating a slice, which similar to list. Let's go step by step. My_tuple equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, result equals my_tuple 2:5, start at index 2, value 3, stop before index 5 include 3, 4, 5. So output 3, 4, 5. Next, result _with_ step equals my_tuple 0:9:2. Start at index 0, end before index 9, step equals 2, skip every second element, so selected values 1, 3, 5, 7, 9. Output 1, 3, 5, 7, 9. Continue with the same tuple. From_start equals my_tuple 5, start from beginning up to index 5, exclusive, output 1, 2, 3, 4, 5. To_end equals my_tuple 5, smiley face, start from index 5 to the end, output 6, 7, 8, 9, 10. Whole_tuple equals my_tuple, smiley face. This creates a full copy of the tuple. Output remains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's go through each function. Given a tuple, t equals 1, 2, 2, 3, 4, t.index 2 returns 1, which is the first position of value 2 t.count, 2, returns 2 because value 2 appears twice len, t, returns total number of elements max, t, returns largest value min, t, returns smallest value sum, t, adds all values together. Each function processes the tuple without modifying it. This slide compares tuples and lists. Tuples, immutable, more secure, faster for access. Lists, mutable, can be modified, suitable for dynamic data use. Tuples when data should not change, such as coordinates or fixed records. Tuples are faster than lists during iteration because they are immutable. They can also be used as dictionary keys, provided all elements are immutable. Tuples are ideal for storing fixed data or mixed data types that should not be changed. Once created, the values remain constant, ensuring data integrity.